Lesson 5-6 is on graphing proportional relationships. And in this lesson, you will be able to identify proportional relationships, and you'll also be able to analyze proportional relationships. Remember, the essential question for Chapter 5 is how can you identify and represent proportional relationships? Proportional relationships are relationships in which a straight line is created by plotting the points. This is not true of the pumpkin data that we analyzed the other day, but proportional relationships do have a straight line, and they do pass through the origin. So we can say that the two quantities are proportional if the graph produces a straight line and it goes through the origin. So you have a graph here on the page 212 to look at, and you can see that center B is colored red and center A is colored blue. And the reason that center A is not constant is because that the relationship between the cost and the number of guests is non-proportional. And then it's a straight line, yes, but it does not pass through the origin. So those are really two main things that you need to remember for this particular lesson, is that yes, we can have a straight line. That's one of the components. We have to have a straight line, but it also has to pass through the origin. And in this case, center A has a straight line, but doesn't pass through the origin. So it's non-proportional, okay? And in center B, we do have a proportional relationship because we do have the straight line and it does pass through the origin. And another thing to point out here is that if we took the y value divided by the x, we're going to get that constant of proportionality. So 100 divided by 10 is 10. 300 divided by 30 is 10. And 500 divided by 50 is 10. So that's going to remain the same all the way through. Whereas if we take the values on center A's line, 400 divided by 0 is undefined. So let's move on here to 500 divided by 25, which is 20. And then 600 divided by 50 is not 20. It's, let's see here, 600 divided by 50. We can cancel out a common 0 here, so we have 60 divided by 5, which is 11, and no, it does come out to a whole number. Sorry, it's late at night and I'm trying to make these videos. So 1, 2, so 12, but the 12 is not equal to the 20 and certainly not equal to 400 over 0. So we don't have that constant of proportionality there. So just a little bit of preview for what we're doing this chapter, this lesson. We're doing some graphing. And if you have graph paper handy, it makes it really nice to see those straight lines, but sometimes you have to create graphs by hand, and they're not so nice. But on your note sheet, I've given you a couple of graphs, but just notice on the notes that I'm doing here, I had to hand make my graphs, but you get the idea. So in example 1, we're taking a look at a horizontal data table, and again, we have our time is x, that's independent, and then our distance is our y value. Our distance is going to depend on the time. That's why my y is my dependent and x is my independent. So what we have here is a table, and it says to graph these points on a coordinate plane. So we did that, and we connected the points, and because it makes a straight line and because it passes through the origin, we have a proportional relationship. The ratios are constant, and so the relationship is proportional. For example B, again, we have a table, x and y, and if we plot those points, we get a nice straight line, but notice it does not pass through the origin. Also, if we took 20 divided by 0, undefined, 16 divided by 2 is 8, 12 divided by 4 is 3, and 18 divided by 1 is 1. When you check all of those, it's not proportional. So they're not constant, and so the relationship is non-proportional. Let's take a look at the got it section at the bottom. Notice that I've written all of those ratios as fractions beneath the table. And in 1a, we have 6 divided by 2, 8 divided by 4, 10 divided by 6. And if you start looking, those ratios are not constant, so it's non-proportional. And then I've also graphed them over here, giving you a chance to graph those two on your note sheet. Notice we have a straight line, but it does not pass through the origin, so it's not proportional. In 1b, we do have a constant of proportionality. 6 divided by 2 is 3, 12 divided by 4 is 3, 18 divided by 6 is 3, 24 divided by 8 is 3, and 30 divided by 10 is 3. And if we graph those points up here, we notice we get a straight line and it passes through the origin, so they are proportional. Remember, we're looking for a straight line and passing through the origin to be a proportional relationship. And tying that into last section, it's also a requirement to be a direct variation. Y equals kx, it has to be something that passes through the origin to fit that, and that will make more sense when we get into graphing linear equations. For the next example on page 214, we're looking at two quantities being proportional, and you can use the graph like we have here to find that constant of proportionality, and then we can analyze some points on the graph. Okay, remember that it has to pass through the origin, so that's this point right here. And then we also have other ordered pairs on the line that we can use to find that constant of proportionality. All right, moving down to example 2, we have a graph here, and it doesn't matter which point you take to find that constant of proportionality. You can take 5 divided by 1 or 25 divided by 5. Either way, you get 5. So the constant of proportionality in this example is 5 millimeters. And what do those points on the graph mean? 0, 0, 1, 5, and 5, 25. It just represents that 0, 0 is the length of the stretch of the spring, 0 millimeters, with no weight attached. 1, 1 is the length of the stretch of the spring, 5 millimeters, when 1 gram of weight is attached. And then 525 is the length of the stretch of the spring, 25 millimeters, when a 5 gram weight is attached. So that would include any points on the line that we can interpret that data point. So let's take one look at the one at the bottom of page 214. We have a graph here that passes through the origin, and it's a straight line, so we know it's a proportional relationship. We can find that constant of proportionality by taking any one of the points here. 18 divided by 9 is 2, 12 divided by 6 is 2, 6 divided by 3 is 2. So the constant of proportionality is 2, and that is actually 2 millimeters. So the interpret it just means that every day it's growing 2 millimeters. So what do the points 0, 0, 1, 2, and 6, 12 mean? Well, obviously at 0 days it's grown 0 millimeters, but at 1 day it's grown 2 millimeters, and at 6 days it's gone 12 millimeters. And this point right here means at 9 days it's grown 18 millimeters. So that is part B of what those mean. Make sure you get those on your note sheet, and you'll have a few example problems to work out independently. Just remember that whether the table is vertical or horizontal, we always have the x and the y value, and you're looking for the relationship on a graph. When it's graphed, this is the x-axis and this is the y-axis, and you can plot these points on a graph similar to what we did with the pumpkin data. We graph the data, and when you graph it, if it goes through the origin and it makes a straight line, we call that a proportional relationship. And we can find that constant rate of proportionality by analyzing the data. Okay? If you have any questions, let me know. Otherwise, work on your examples and your homework, and let me know if you have any questions.